So let's look at how differentials can actually get used in real life, mostly by engineers and physicists. So, me being human, if I measured something, I would probably be off. So here's what it would look like. My measurement would be the exact amount plus the amount of error that I made. And if you've ever measured anything, you know the rule about, especially in woodworking, measure twice, cut once. So there's always room for human error, especially when you start measuring things that are really tiny measurements. And so that delta x would be the error. So then, of course, if I used that measurement, so now let's say I'm already off and I'm going to use that measurement to make some other calculation, like let's say area or volume, well, of course, then I'd have an error in that too. And that fancy area, or fancy error, is called propagated error. And so we might represent that propagated error as, let's say, delta y. So the amount that my new value y is off as. So this error is the value between the exact measurement, the one I should have gotten, and the one that I calculated from using my bad measurement to start with. So we then could say that delta y could be found by taking the y value from my measurement. Remember, this was my measurement, so the y value would be this, and subtracting the correct y value, which would be from the exact part of the measurement. And then to figure out the relative area, of course, relative just means that it's based on a total or the whole, so it's going to be a percent. And so I would take my estimate and put it over the actual. And we'll remind ourselves what that actually means. dy would be my estimate, and y would be my actual y value. All right, so let's look at an example down here on number 1. So I'm calculating the area of a triangle, and I want to know that how much error I'll have if my measuring is not so good. So of course I have my formula for area of a triangle, and I would need to know what the actual area is and what my estimate is with the errors in them. So here's what I know is that the base and height are 36 and 50, and then I have possible error in each measurement of 0.25, so that's my differential. That's how much I'm off, potentially. So of course, if I plug in those measurements, I can calculate the actual to be 900. And if I look at, well, how much might I be off? So let's look at the differential. And in order to do that, I'd have to take the derivative of this. Oh boy, that's going to be product rule. So it'll be base times the differential for the height plus the height times the differential for the base. And then I can just plug all of those values in. So I now have 36 times 0.25, which is my DH, and 50 times my 0.25, which is my dB. And of course, all of that stuff inside is 21.5. And so half of that, I get 10.75.